Okay, my clock just switched to 10:30. Whoops, sorry about that. My clock just switched to 10:30, so I'm going to jump in and get started. Good morning, everybody. Hi. Hello.
Morning.
Good morning.
Morning.
Good morning.
Good morning. A big thank you to the 31 of you who are here right now. I guess 32 counting, or 31 counting me. So let's jump in and let's get started. So today we're going to continue talking about temperature, but we're going to be talking about it from a slightly different perspective. And a good launching area. One of the things I love about summertime here in the Bay Area is, for the most part, if I want to get away from the heat, all I have to do is just drive to another part of the Bay Area. So right here is a good example of this. San Jose and San Francisco are only about 40 miles apart. In terms of climate, that's actually nothing. They're pretty much in the same region. I'm actually going to post the link right now. So here we go. And I can also post it in Canvas real quick. But San Francisco and San Jose are only about 40 miles apart. And yet they have very different temperature swings. If you take a look, San Jose gets quite a bit warmer during the summertime. San Francisco, not as warm during the summertime. So the seasonal temperature differences from winter to summer is much bigger for San Jose than it is for San Francisco. Why do you think that is? So to answer that, I'll post this link again. I'll also post it on Canvas right now. Whoops. But take a moment, write down your thoughts on that Google form, and then we'll talk about it. Oh, God. On Canvas, I think I posted the wrong link. There we go, I fixed it. So I'll post it here again. So as people are trickling in still, let me post it again in chat. I'm starting to get some responses. And a huge thank you to all of you with your webcams on. It really makes a difference. Thank you so much. So happy seeing faces. All right, let me paste the link again. Okay. All right, take another minute. For those who have trickled in, I can paste the link one more time. Okay, I've got responses from almost everybody in the room. So as always, I'm not looking for a perfect answer. I'm just looking for your thoughts. And let me put up what people are saying. So San Jose has a very different location compared to San Francisco. So if you are in San Jose right now and you look around, on a clear day, on a smogless, smokeless day, on a day with good air quality, if you look to the west, you see mountains. If you look to the east, you see mountains. If you look to the south, you see mountains. We are pretty much entirely surrounded by mountains and a smidgen of bay to the north. So we really have the features and the climate of an inland city. And inland cities typically get warmer during the summer and a little bit cooler during the winter. They tend to have much bigger temperature variations. On the other hand, places like San Francisco are on the bay. And not only is San Francisco itself on the bay, it is surrounded on 3 of its 4 sides by the bay and the Pacific Ocean. On the western part of San Francisco, you have the Pacific Ocean. The eastern part, you have the San Francisco Bay. The northern part, that's where the Golden Gate Bridge is. You have a good chunk of bay there too. And so San Francisco is mostly surrounded by water. Areas near water have much more moderate temperature variations. They don't get too hot in the summer. They don't get too cold in the winter. Now, that being said, San Francisco also has a different big important component to it that I'll actually talk about later in class. And it has to do with the kind of water that's near San Francisco. But just looking at what people are saying here on the responses to this question, a lot of people have been mentioning this. So a lot of it has a lot to do with, being right next to the ocean for San Francisco, being further inland for San Jose. That's one of my favorite things about living in the Bay Area. I love the microclimates of this area. I love the microclimates of this area. I think they're cool. Like, I get really blown away by it. I geek out about it like I am right now. So the geography of the region really makes that happen. That being said, what we are talking about today has to do with these temperature variations and how they change throughout the seasons. So that's what we're talking about today. All right, let me switch back over to my presentation for today. And let's jump in and let's get started. So there's a little bit of terminology to today, and I think that students tend to get kind of lost in this terminology. So I'm going to try to take it slow. There's some really cool stuff though, and I actually have a few polls I'm going to be asking in class. I think this is really fascinating stuff. So here we go. First off, let's talk about what a temperature swing is. That's my phrase for it. It's basically a variation. a temperature variation. It's how much the average temperature changes throughout a year. Obviously, in the summertime, it's nice and warm. In the wintertime, it's usually much cooler. Well, how much of a difference is it between summer and winter? That's what we call the range. So when I talk about temperature swings, I'm just talking about the range of temperatures from one location to another and how they change seasonally. So for example, what I have here, this is actually San Jose's I know I said a dirty word. Oh, real quick, one other thing I want to mention really quickly. I have had major internet issues over the past day. My earlier class said that at times my video cut in and out. If that happens, I profusely apologize. I need to get on the phone with AT&T and figure out what the hell's going on. Threaten to switch to Xfinity if I have to. Hopefully that's not required, but we'll see. But please bear with me with that. I'm going to try to get through this. I apologize for that. Okay, now with that said, looking at San Jose, throughout the temperature swing, we would want to identify the warmest temperature and the coldest temperature, and then simply take the difference between them. So the warmest temperature for San Jose, right here, 82 degrees, and it's that both in July and August. Coldest temperature, 58 degrees, and that's in both December and January. So San Jose's temperature swing is simply 82 minus 58. And that gives us a temperature swing of 24 degrees Fahrenheit. San Francisco is less than half that. Even though San Francisco isn't really that far away from us, because they're next to the ocean, they have a much smaller temperature swing than us. So what are some of the things that can actually affect how big this number gets? There are some places in the world, in fact, there's one place where the seasonal temperature swing is bigger than 100 degrees Fahrenheit. That's right, bigger than 100 degrees. And then there are other places where the temperature difference from winter to summer is as little as 1 to 2 degrees. So what are the factors that affect this? Well, there's actually 4 of them. There's actually 4 of them. And the 4 factors are latitude, proximity to the ocean versus land, the 4 things. These are the 4 big factors that impact seasonal temperature swings. Latitude, proximity to water and land, elevation, and ocean currents. One thing are tempted to copy down this slide and put this on the quiz test or whatever. But these are just super brief summaries. There's so much more going on here. And so you definitely want to pay attention to these next few slides, as tempting as it is. So these are the 4 main factors: latitude, proximity to water versus land, elevation, and ocean currents. Latitude greatly influences incoming sunlight. Latitude greatly influences incoming sunlight. Oh, whoops. Latitude greatly influences incoming sunlight. Being next to water can greatly cause moderation in temperatures. Elevation, I think that one's a little bit more self-explanatory here in the troposphere. As you go up, temperatures typically go down. And then finally, ocean currents. There's a reason why most of the West Coast is super foggy during the summertime. Whereas if you go to the East Coast of the United States, it's very, very different. So let's talk about these 4 things in depth. If you didn't get all this written down, don't worry, we're going to go into it in depth now. First, let's talk about latitude. So latitude is simply the distance from the equator. I've briefly mentioned it before. It's simply the distance from the equator. Well, if you live near the equator, if you essentially live right near the equator, the truth is that the sun is almost always overhead. Not only that, but if you live near the equator, the length of daylight doesn't really change throughout the year. So areas near the equator experience warm temperatures and very consistent temperatures. What this means is that temperatures don't really change much from winter to summer near the equator. In fact, just last week, I was talking with a friend who has missionaries in Nicaragua, and she was debating with her husband about which season it is in Nicaragua. And one of the things that actually came up is that they view seasons very differently than we here in North America view them. The reason why is because they're right near the equator. Down there, the difference between winter and summer is very, very small. The difference between winter and summer is very, very small. As a result, they actually define their seasons culturally. This is how they do it culturally, more so based on what time of year they're getting their rain. During the summertime, during the months of June, July, and August, that's when they get all of their rain. During December, January, and February, that's when they don't get rain. So they consider June, July, and August to be their winter, and December, January, and February to be their summer. But really the reason why they do that, though, is because the temperature doesn't really change much throughout the year there. And that's true for all areas near the equator. So near the equator, you get very little temperature change. Very little. Then we go further away from the equator. We get into what are called the mid-latitudes. This is where we live. We live in the mid-latitudes. Roughly, the mid-latitudes are defined as the region between the Tropic of Cancer, Capricorn in the Southern Hemisphere, and then the Arctic Circle, or the Antarctic Circle in the Southern Hemisphere. Roughly between 23.5 to 66.5 degrees. These areas see a pretty moderate variation in temperatures. During the summertime, it can get nice and warm. During the wintertime, it gets pretty cool, in some places even cold. The reason why this happens more than anything is because of the difference in day length. I'm sure you're all noticing it now. It's definitely getting darker much earlier now than it was even just a month ago. It's getting darker earlier and earlier and earlier. Just a month ago, the sun was out way past 8 o'clock. Now the sun is going down around 7:30. In a few weeks, it'll be going down around 7, then 6:30. That's because in our wintertime, our days are much shorter than they are in the summertime. As a result, we get much less radiation, much less heat in the wintertime than we do in the summertime. Therefore, exactly, somebody just messaged me a good definition of seasons down near the equator. But what we actually get here is much cooler in the wintertime because we get much less sunlight, much warmer in the summertime because we get more sunlight. And then we get up to the poles. Has anybody ever been to a city let's say in Northern Europe, Alaska, Northern Canada, Iceland maybe. Anybody ever been to a city like that? I've been to Alaska before, but only the extreme southern portion of Alaska. Those areas, and in fact, just even further north of here, in cities like Portland or Seattle even, those areas see much greater variation than we even do here. And one of the reasons why is because the length of the day becomes much greater. If you live anywhere between 66.5 degrees, that's what's called the Arctic Circle, and the pole, you actually will get at least 1 day a year, where the sun does not set. Think of that. A day of the year where the sun does not set. It is sunlight 24 hours. That is insane. Try sleeping in that. I couldn't imagine having to do that. But there are areas in Canada, Siberia that actually experience that. And so they get a lot of sunlight. The good news is for those regions, the sun is still very, but it's still enough and it's out for long enough for them to get nice and warm. On the other hand, in the wintertime, those same regions actually experience days that are 24 hours of darkness. Meaning no sunrise at all. Imagine trying to be productive on a day where the sun does not rise. Yee, I wouldn't want to do that. I'm having a hard enough time being productive during COVID as it is. I wouldn't want to have COVID plus 24 hours of darkness. I would be depressed. Well, all of this puts together to actually create pretty insane temperature variation. Can anybody hear me right now?
Yes.
Yeah, I apologize for how terrible my my internet is. I am so sorry. Thank you. So near the equator, very little change. The sun is always high, 12 hours of daylight every day. However, the further away you get from the equator, the greater the variation becomes. And the greater the variation becomes, and you don't need to know this you don't need to understand these diagrams super intensely. I just want you to know near the equator, the further away you get from the equator, the greater the change becomes. The further away you get from the equator, the greater the change becomes. By the time you make it to either the North Pole or the South Pole, the change is extreme. So very little change near the equator, extreme change. The further away you get. So very little change near the equator, increasingly extreme the further away you get. So maybe it would be worth writing a little change right here. Even more change, oh gosh. Even more. change, lots of change. And then extreme change. So if you live near the equator, the temperature difference between summer and winter is almost nothing. The further away you get from the equator, the greater the temperature change becomes. And we end up seeing something that looks kind of like this. So these are areas with, so here's what this graph is showing. This is actually showing the average January temperatures. Notice near the equator, as would be expected, it's nice and warm. As you get away from the equator, it gets cooler. But if you actually notice here, which hemisphere has the cooler temperatures? The northern hemisphere. Which hemisphere has the bigger, or has
Northern.
the northern hemisphere? Absolutely. The northern, look, up here in parts of interior Siberia, the temperatures at times drop below -50. And guess what? People actually live there. I'm not kidding. People live there. That's insane if you ask me. All right. Well, that being said, if you take a look at the southern hemisphere, down here, you notice that you don't see as big a temperature change. So everything north of the equator is experiencing winter. Everything south of the equator is experiencing summer. All right. Now what I want you to do right now, I'm about to switch from January to July. What I want you to do is first remember what the temperatures were near the equator, mostly 80s. Then I want you, and in fact, I will actually put my laser pointer. I have a little laser pointer that I can use here. Right up here in interior Siberia. Right now in January, the temperature is below -50. Let's see what it is in July. That same area, the same area. If you look near the equator, temperatures are still in the 80s. But if you look at that area in northern Siberia, the temperature went from below -50 to above +50. That is a 100-degree temperature swing between winter and summer. That's insane. Like, that is so crazy. But it just goes to show you, the further away you get from the equator, the more extreme the temperature difference from winter to summer becomes. If you notice near the equator, once again, very little temperature difference from, winter to summer. However, the further away you get from the equator, the bigger the temperature difference from winter to summer becomes. The worst of it is in this area in interior Siberia. But there are other places as well that see it. Much of northern Canada, the temperatures were in the 40s and 50s, and now they're in the -10s to -20s. That's a 50-degree temperature swing right there. So yeah, the further away you get from the equator, the bigger the temperature swing becomes. All right, I'm going to try something very new now, or something that I've never done before. I'm actually going to try a poll here on Zoom. So I have two cities here, and they're seasonal temperature variations. So basically these are two graphs that show you the temperature for each month. Which city is city A or city B? That poll. Now let's see what people say. So city A or city B? Remember, the closer you are to the pole, the greater the temperature difference throughout the year is going to be. The closer you are to the pole, the bigger the temperature difference is going to be. The closer you are to the pole, the bigger the temperature difference is going to be. Okay, I've got 46 of you have voted. Okay, 47 of you have voted. 48 of you have voted. Okay, there's still some people who haven't voted yet. D. Another few moments. Okay, 51. 52. So hopefully 5 of you aren't asleep at the stick. Okay. So here's what I got. So the results were 41 of you, that's 77%, that's 3/4 of the class, city B. 12 of you, 23%, I can click share results. So you should be able to see them now. So yeah, so 41 of you clicked city B, 12 of you clicked city A. So remember, if you're near the equator, you're going to have very little temperature variation. If you look at city A, the difference between winter and summer is incredibly tiny. On the other hand, if you look at city B on the other hand has a much bigger temperature difference. Very warm in the winter, or sorry, very warm in the summer. Not so warm in the winter. Very warm in the summer, not so warm in the winter. So definitely a very big temperature difference. So the correct answer here is city B. City A is Bogota in Colombia. City B is Barrow in Alaska, the northernmost city of North America. Now, if you may notice, Bogota, for being a city near the equator, the actual temperatures themselves aren't that high. Anybody want to guess why Bogota, even though it has a very small temperature variation, it's not very warm there? Anybody want to guess why that is? Okay, one person says it's near the jungles. Somebody else said because there's no sea. Okay, one person says sea level. Yeah, actually, Bogota in Colombia has an elevation of around 9,000 feet. An elevation of around 9,000 feet. That's why it's not super warm there. But if you notice, the temperature differences are very, very small there. Very, very small there. Whereas the further away you get from the equator, Barrow in Alaska has a pretty big difference in temperature. In the summertime, the temperatures are around 47. This is the average high temperature, around 47. In the wintertime, the temperature can dip as low as -8. So that is a 50, let's see here, 47 plus 8. That is a 55-degree temperature difference from winter to summer. That's a big temperature difference. So somebody just asked me, why does Bogota have lower temperatures around summertime? That's because it's in the southern hemisphere. So Bogota's not right on the equator. It's slightly away from the equator. It's actually, it has a latitude of around 5 degrees south. Now in the southern hemisphere, summer is December, January, and February. The wintertime is June, July, and August. So that's one of the reasons why. Good question. All right, let's get into the next big factor. The next big factor is proximity to water. To water can also play a big role in how temperature changes throughout the season. So to demonstrate that, here are two cities, St. Louis and Punta Delgada. Oh, hang on. Sorry about that.
Bless you.
Thank you. So these two cities actually have very similar latitudes. But St. Louis is inland. Oh, sorry. I always sneeze in multiples. Something just tickled my nose. It's nothing else. Meanwhile, Punta Delgada in the Azores is out in the middle of the Atlantic Ocean. Well, if you take a look, St. Louis has a temperature range of about 50 degrees Fahrenheit, whereas Punta Delgada only has a temperature range of around 14 degrees Fahrenheit. Well, here's what's going on here. Water has a very interesting property to it called a high specific heat. Specific heat is the amount of heat that an object needs to absorb in order for it to warm up. How many of you have been to our beaches over here, like Santa Cruz, Half Moon Bay? How many of you have been to our beaches during the summertime? How's the water like? It's cold. Yeah, it's very cold. Even in the middle of a hot afternoon day. Meanwhile, the sand, assuming that you're someplace that's sunny, how is the sand like during the daytime? Not kind of throws us off here in the Bay Area, but it's typically very hot. Yeah, during the summertime, and especially in the middle of the day, the sand can get very hot, whereas the water stays very cold. Well, the reason why is because it takes about 5 times as much heat to warm water as it does to warm that sand. Water has a higher specific heat, the amount of heat necessary for it to heat up, for its temperature to increase. So very, very, very hot. On the other hand, the water doesn't heat up much during the day. Now, what about at night? How does that sand feel at night?
Cold.
At night, the sand gets cold. Meanwhile, the water doesn't really get much colder. The water temperature doesn't really decrease much at night. Now, I'm not going to ask if it feels warm because here in California, the water always feels cold. but it doesn't really get any colder at night. So here's what this all does. Areas that are near the water are subject to much more moderate temperature swings because the water doesn't get really hot during the day. It doesn't get really cold at night. The same difference is true from winter to summer. It doesn't get really hot in the winter, doesn't get really cold in the summer. Ocean temperatures stay, they vary, but they don't vary by much. So areas right next to the ocean are very influenced by that due to sea breezes. As a result, there's more moderation, therefore there's less variation. And this is seen right here. Punta Delgada in the Azores, Punta Delgada here in the Azores has a very small temperature variation compared to St. Louis, which is very far inland. All right, that brings me to my next poll. Which of these two cities is closer to the ocean? Now, what you want to do, don't just focus on the shape of the curve. Focus. So here we go. Let me click on stop sharing here. And let me, all right, so which city is closer to the ocean? City A or city B? Which city is closer to the ocean? City A or city B? So what you're looking for here, the city closer to the ocean should have the smaller temperature difference between winter and summer. Cities near the ocean have a small temperature difference. Cities inland are going to have a bigger temperature difference. All right, so I've got 42 responses. Let's take another 30 seconds. So I'm coming up on a minute now. All right, another 30 seconds to get your vote in. Another 30 seconds to get your vote in. Okay, now another 15 seconds. So far, 48 people have responded. 49. 50. All right, last call for votes. Somebody messaged me City A. All right, so let me share the results. And here are the results. 41 of you, that's 82%, said City A. 9 of you, 18%, said City B. Okay. So the bulk of you are seeing that. And that is correct. City A is right next to the ocean. That's actually my hometown of Long Beach, California. City B, on the other hand, is Dallas, Texas, a city I don't understand why anybody would want to live there. Ridiculous heat in the summertime, ice storms in the wintertime. It sounds horrible. I don't want to live there. But interestingly enough, they're at the same latitude as Long Beach. The only difference is they're much further inland. Dallas is in the middle of North America, whereas Long Beach is right on the west coast. Okay, the next one's a little bit easier, a little bit more straightforward. Elevation. So here's how elevation works. Very complicated. Yep, tornadoes and floods in between. Higher up you go, the colder it gets. This is one of the reasons why, if you notice during the winter time, those of you who live here in the Bay Area during the winter time, in non-pandemic times, if you've ever looked at the hills to our east, those are those brown hills, the dry brown looking hills. They kind of turn green in the wintertime. Okay, somebody said, can you explain why it's not Dallas? So Dallas is very far inland. Areas that are inland get much bigger temperature swings than areas near the coast. So Long Beach, which is right on the coast, gets a much smaller temperature variation because it's on the coast. It doesn't heat up as much, it doesn't cool down as much. Whereas land gets really, really hot during the summer, really, really cold during the winter time. Hope that helped. Are there any follow-up questions to that? Awesome. So yeah, so typically, so going back to this, if you notice some of the mountains to our east, so those are those brown mountains. The tallest one is Mount Hamilton. If you've ever looked at it, there's like a little white building on the top of it. That is the Lick Observatory in Mount Hamilton. Mount Hamilton at times gets snow during the wintertime. And many of those mountains, you'll notice during the wintertime, they'll have a little dusting of snow on top. We don't get snow down here in the Bay or in San Jose, though. The reason why is because temperatures cool as you go up. All right, that brings me to poll number 3. So here, let me just tell you 2 things really quickly. Both of these cities are inland. Both of these cities are at the same latitude. Which of these 2 cities has a higher elevation? Let me switch to that poll. Which of these 2 cities has a higher elevation? City A or City B? Which of these 2 cities is at a higher elevation? City A or City B? The city at a higher elevation should have should be colder in general. So the city at a higher elevation should be colder in general. Whereas the city lower in elevation should be warmer in general. All right, about 30 more seconds. I've still got 9 people who haven't voted yet. Five more seconds, last call. And then I will end the poll. And here we go. So 42 of you, 78% said city A. 12 of you, 22% said city B. Let me click on share results so that you can see that. Okay. Now, if you notice, if you look at city A and city B, they both have very similar temperature swings. The difference from winter to summer is very similar to both of them. But if you notice, city A overall, so city A overall is much cooler than city B in general. If you take a look at each month, city A is cooler than city B. And yep, city A is at a higher elevation. Sorry, somebody messaged me saying that the polls aren't showing up for them. Chances are the Zoom that you have might be outdated, so you might want to update it. So right now, I'm not doing any of these for like a score or anything like that. So it's okay if you message me your answer in chat. That's totally fine. So I'm so sorry about that. But yeah, I think that that's actually an issue with the version of Zoom you have. Thank you for letting me know, though. Okay. And we have one more factor to talk about. And then we're going to do a little exercise, and then we're done for the day. Okay. The last factor has a lot to do with why our waters are so cold. If you've ever been to the beach here on the West Coast, anywhere on the beach, Huntington Beach in Southern California, Santa Monica, Pismo Beach, Morro Bay, Big Sur, Monterey, any of those areas, our waters are pretty cold. Pretty much anywhere along the West Coast of the United States, our waters are pretty cold. But how many of you have ever gone to the beach on the East Coast of the United States? Jersey Shore, Florida, Miami, anywhere on the Gulf of Mexico, Galveston. Has anybody ever been to the ocean on the East Coast? I see lots of shaking heads. I totally understand, but has anybody? I have, but I also want to have a second testimonial. Nobody else has ever been to the beach on the East Coast of the United States? Okay. Well, the ocean waters on the East Coast of the United States are much, much warmer than they are here. In fact, in parts of the Gulf of Mexico, the temperature of the ocean water can be as high as 90 degrees Fahrenheit. Our ocean waters off our coast top out at 60. So it is much, much hotter. The ocean waters are much, much hotter there. As a result, those areas, especially during the summertime, tend to get much, much warmer and much more humid. They tend to get much more humid than we do here. I know, I don't want to deal with that. Well, areas near cold ocean currents, like our current, the California current, are typically very mild and typically very dry. We don't get a lot of rain, especially in the summertime. We don't get a lot of rain here. It's because we're next to a cold ocean current. On the other hand, on the other side of the United States, the eastern half of the United States, pretty much anywhere east of the Rocky Mountains, they have exposure to a lot of warm ocean waters. There, it gets really hot and really humid. Has anybody ever been anywhere on the East Coast? Maybe not at a beach on the East Coast, but has anyone ever been to like Washington, New York City, South Carolina, North Carolina, Georgia, New Orleans, Louisiana, Houston, Texas? Has anybody ever been to any of those areas? How does it feel during the summertime in those areas? Okay, somebody messaged me saying they've been to Houston. There's a radio show I listen to from Houston that I still listen to this day. But yeah, very hot, very muggy, very miserable. One time I decided to visit Washington, D.C. in the middle of the summer. Big mistake. It was hot, muggy, sticky, miserable. Oh my gosh, it was horrible. I tried to do sightseeing. I gave up because it was so bad. The next day I, did one of those tour companies and it was way better. But yeah, no, it was depressing. It was because they're next to a warm ocean current. And so the waters are much warmer, therefore the air is the waters are warmer, there's more evaporation, much more humid. A good comparison here are these two cities on this graphic. So I took this from a different textbook. This isn't from our recommended text. It's from a different book. But these two cities are Arica, right on the Peru-Chile border, like right on the Peru-Chile border, and Rio de Janeiro in Brazil. The two cities are at just about the same. They're both right on the ocean. They're both at sea level. But because Arica is next to a cold ocean current, its temperatures on average year-round are about 10 degrees cooler than Rio de Janeiro's temperatures. Arica is located in the Atacama Desert. That is the driest place on Earth. Arica's average annual rainfall is less than 2/100ths of an inch. Just for perspective, we get about 15 inches here. That's our average annual rainfall. So they get nothing. They get nothing, whereas we get lots of rain compared to them. Rio de Janeiro, on the other hand, gets about 35 inches of rain a year. So it's much warmer, much muggier, much wetter. All right, last poll. And then for those of you who the polls aren't showing up, I apologize for that. You can put your answers in chat. That's totally fine. It is very likely the version of Zoom you have. But here we go. Let me switch to the next temperature profile. Which of these cities is near a warmer ocean current? Which of these cities is near a warmer ocean current? So which of these cities is near a warmer ocean current? Which of these cities is near a warmer ocean current? Which of these cities is near a warm ocean current? All right, let's take about 15 more seconds. And I think I've got just about everybody's votes. And let me share these results with everybody. So you can see what the overall response was. City A got 8 votes, or 16% of the vote. City B got 43 votes, or 84% of the vote. And then somebody else messaged me City B. So that being said, yeah. City A is San Diego, which is located on the west coast of the United States, right near a cold ocean current. Whereas City B is located in Savannah, Georgia. That's on the east coast of the United States, next to the warm Gulf Stream. Definitely much warmer there, especially in the summertime. if you notice their temperature differences aren't big during the wintertime, there's another reason why that happens. Obviously, ocean currents aren't the only thing that affect a location's temperature. Other things affect it as well. But for the most part, you definitely see that influence of ocean water in both of these cities. And they're both very similar latitudes. They're both very similar elevations. They're both right on the coast. So City B was the correct answer here. It's near the warmer ocean current. All right, let me shut off this poll. Let me shut off this poll real quick and then, okay. Last few things I want to talk about, and then I'm going to do a very brief activity and then we're done. So, human comfort. As I mentioned at the beginning of all this temperature talk, temperature is essential to human comfort. It's one of the reasons why when people hear the word weather, they oftentimes think of temperature, because that's the first thing that comes to mind. When you hear the word weather, you think of temperature. Well, the reason why it's so essential is because just like when you take an ice cube and you put it out in a warm room, there's a difference in temperatures that causes heat transfer to occur. Well, our bodies are at a roasty, toasty 98.6-ish degrees Fahrenheit. Well, if you are in a room where the temperature is below 98.6 degrees Fahrenheit, your body is going to be giving off more heat than it's receiving. As a result, your body temperature is cooling down. Now, the good news is because of metabolism, that heat does get replenished. However, if the temperature is way colder than 98.6, let's say the temperature is 60 or 50, and you stay outside completely naked, don't do that, obviously. That can get you into lots of trouble. But if you are completely naked, therefore you don't have any protection on your body, nothing keeping you warm, well, what'll happen is it will begin to feel, your body will give off more heat than metabolism can replace. What that does is that causes the temperature of your body to begin to decrease, and it can trigger something called hypothermia. How many of you think that wind actually affects temperature? How many of you think wind actually affects temperature? All right, so I'm getting a few people messaging yes. So here's the thing about wind. Wind does not actually affect temperature. Wind actually affects how temperature feels. I'll say that again. Wind doesn't actually affect the temperature. Instead, it affects how it feels. Here's why. So, wrapped around your body right now, wrapped around every portion of your body, is a very, very thin blanket of warm air. Basically, the air right next to your body heats up because of your body due to conduction. Well, when it's windy, that warm layer of air that's wrapped around your body gets blown away. Your body then replaces that with more warm air that causes your body to lose heat. Therefore, when it's windy, because that warm layer of air near your body is being blown away, it feels colder. We call that a wind chill. So a wind chill is the temperature that the wind makes the air feel like. This isn't the actual temperature. This is just how, this is the temperature that it feels like to your body. On windy days, the wind chill temperature can be substantially lower than the actual air temperature, because if the wind is strong enough, It's blowing that warm layer of heat away from your body, that warm layer of air away from your body, and it gets much, much colder. And typically, the faster the wind, the colder it feels. The faster the wind, the colder it feels. So here's the wind chill index. And it works just like a data table. You have two axes here. Up here, this x-axis represents air temperature in Fahrenheit. Down here, these represent wind speed. So let's say the temperature outside is 5, and we have a wind speed of 15 miles per hour. For a temperature of 5 and a wind speed of 15 miles per hour, that would give us a wind chill of -13. Let's do another one. Let's say -30 and a wind speed of 50. -30 and a wind speed of 50. In that environment, the temperature outside would feel like -74 degrees Fahrenheit. The coldest I've ever experienced actual air temperature was a balmy, sweaty, sultry 2 in Chicago. But the winds were actually really fast, that we had winds of roughly 20 to 25 miles an hour. So the wind chills were well below 0. It was so cold, it burned. That's insane if you ask me. It was so cold, it burned. Well, what are some of the consequences of cold air on your body? I mentioned hypothermia briefly. Basically, hypothermia occurs when the temperature outside is so cold. Ooh, I just got a good question in chat. Once I finish this point, I'm going to answer that question. There's another element to it as well. So your body, when your body's giving off of heat, it is cooling down. Its temperature is decreasing. Its temperature is decreasing, right? If it gets below a certain temperature, it becomes hard for your body to function properly. And that can actually cause your organs to shut down, and that could actually lead to death. This can even happen at relatively mild temperatures. If you aren't wearing any clothes, that's why I said the naked body believe it or not, the naked body at a temperature below 68 Fahrenheit begins to shiver. At around 50, you can actually begin to start experiencing hypothermia. Now, if the temperature is even colder than that, your extremities, your hands, your feet, they're actually the coolest part of your body. Why? Because they're the farthest away from your heart. And if they're the farthest away from your heart, that means that it takes that warm blood the longest to get to them. Well, when it's really cold outside, your extremities can actually begin to experience very cold temperatures. And in fact, the temperature can actually decline to below the freezing point. Well, get this. Our bodies are mostly made up of water. If the temperature gets below the freezing point, that water begins to freeze. So the water in your fingers and toes can begin to freeze. That is what's called frostbite. At that point, it begins to discolor, it begins to deform, it begins to look really, really freaky. I have an image on the next slide that is not for the faint at heart. Now, before I get to that image, I got two really good questions in chat. The first one was the feels like temperature you get on your weather app. So if you open up your weather app, let's see here. If you open up your weather app, you'll see something kind of like this that says feels like. AccuWeather calls it real feel, like different people give it different names. Well, wind and humidity both impact how it feels outside. So that feels like temperature takes those two things into account. I don't know exactly how they calculated based on those two things, but those two things are what they take into account. And then somebody else asked me, what temperature does wind chill start equalizing? Well, another key component of wind, which we're going to talk about in about 3 weeks when we talk about what's called advection, is that wind can bring hot air with it. Usually on hot days, the wind that's blowing is typically a very hot wind. So that wind, as it's removing heat, it's also replacing that heat. And so on really hot days, the wind might not make you feel very cold. And that's one of the reasons why when the temperature gets high, even having a fan really doesn't help much. It's just blowing the hot air around. All right, last thing I'll show you, this horrific picture. Not for the faint at heart. Close your eyes if you don't want to see it. This is how bad frostbite can look like. I mean, look at those fingers. The fingernails are black. They are swollen, discolored. Here's the crazy thing. Nice claw. Here's the crazy thing. These extremities, these fingers, were saved. He did not have them amputated. They were actually able to save them. But that's how bad frostbite can get. Your whole body, these extremities can completely discolor, swell up, deform. It is horrible what can happen to them. And so that's one of the reasons why temperature is essential to human comfort, because when temperatures are low, you can begin to get things like that. Your extremities can begin to freeze. And if it's not taken care of, you can actually lose fingers and toes and feet and hands. And there's some pretty freaky stories about people trapped in blizzards who've experienced really bad frostbite. Thankfully, that hand was completely saved. There was probably some nerve damage on the inside of the hand due to that, but for all intents and purposes, it was saved. All right, I had a temperature conversion activity, but we ran out of time today, so I'm going to save that for next time. That's it for today. Thank you all so much for bearing with me and my lousy internet connection. I will have it fixed by next time. Thank you all so much for putting up with that, and thank you all so much for your patience and for sticking with me. If you have any questions, comments, concerns, I can hang out for a few minutes. Otherwise, I will see you all next time. Bye.
Thank you so much. Have a nice day.
Have a great day,
Thank
everybody.
you.
Bye. Thank you.
Professor,
Yes, how can I help?
I have a question. How will the final exam be?
Oh, okay. So the final exam is going to be a 50-question multiple choice test, and it will be comprehensive, but rather than making you look up go back and look up all your old notes and stuff like that, I actually give you a sheet with everything you need to know on it.
Oh, okay.
And so you review that and take the final.
Okay, thank you.
Yeah, absolutely. Any other questions, comments, concerns, threats, things I can help with real quick? I can hang around for a few moments. Then I got to get on the phone with AT&T and yell at them about my my internet service. I can hang out for a moment. Okay. I'm gonna log off. Once this recording is saved, I will upload it once I get my internet fixed, which hopefully will be this afternoon. All right, I will see you all later.